Why are elasticity and ductility key for giant structures? Imagine a skyscraper swaying gently in the wind or a bridge bending slightly during a storm. These movements are not accidents but carefully planned features that keep structures safe and strong. When engineers design colossal creations like tall towers, long bridges, or massive stadiums, they face many tough challenges. These structures must handle forces from nature and everyday use without breaking apart. That is where the properties of elasticity and ductility come into play. Elasticity is the ability of a material to stretch or bend and then return to its original shape once the force is gone. Think of a rubber band that snaps back after you stretch it. For giant structures, materials like steel and concrete are chosen because they are elastic enough to handle wind pressure and small tremors. When a skyscraper sways in the wind, its steel framework flexes slightly. Thanks to elasticity, it can move without cracking or losing its shape. This flexibility helps prevent damage over time from repeated stresses. Ductility is the capacity of a material to undergo large amounts of deformation before breaking. It means the material can bend, twist, or stretch significantly without snapping. Picture bending a metal wire or a paperclip without it snapping. For huge structures, ductility is vital during extreme events like earthquakes or strong storms. If a building is ductile, it can bend and absorb energy from seismic waves instead of collapsing suddenly. This ability to deform plastically acts like a safety valve, giving warning signs before failure. Engineers design with ductile materials so that, even in the worst conditions, the structure can survive and protect lives inside. In the world of record-breaking structures, these properties are essential. Tall buildings must sway to avoid breaking in high winds, and bridges need to flex during heavy traffic or seismic activity. For example, the tallest skyscrapers use high-strength steel that is both elastic and ductile. This allows them to bend slightly without cracking and to absorb energy during earthquakes. Concrete used in these projects is often specially formulated to be more ductile, helping it withstand extreme forces. Engineers also test these materials extensively before using them in real projects. They push samples to their limits in labs to ensure they can handle the stresses of giant structures. When a new world record is set with an even taller building or longer bridge, it is the combination of elasticity and ductility that makes it possible. These properties allow structures to endure daily stresses and rare but powerful events like earthquakes or hurricanes. Without elasticity, a building might crack or break under small movements. Without ductility, it could suddenly fail during a big quake, causing disaster. Together, these qualities give engineers the confidence to push the boundaries of what is possible. They help turn ambitious ideas into safe, resilient structures that can stand for decades or even centuries. So, when you see a towering skyscraper or a sprawling bridge, remember that it's not just about size and design. It's about the smart use of materials that can stretch, bend, and recover, making these colossal creations possible and safe for everyone.